Welcome to the AI Chat Podcast. I'm your host, Jaden Schaefer. In today's episode, we are honored to have Massoud Alibakhsh, a tech industry veteran and founder of Newsoft. He has a career spanning from software engineering for financial systems to consulting for companies like Microsoft and IBM. And Massoud is a multifaceted innovator. He was the driving force behind NewMD, which is a pioneering cloud-based medical management system, which was acquired by a Fortune 500 company in 2018. Currently, Massoud is working on revolutionizing human and machine communication through his latest venture, which is Omadeus. Thank you so much for coming on the show.
Thank you for having me, Yed, and thanks for that intro.
Talk to us a little bit about what it is that Omadeus does, and why you believe perhaps today with AI is a shift that is going to help propel that forward.
Yes, this is something that I feel like I discovered it back in 2017. I'd been thinking about it and working on it, and as I was explaining and building these tools and trying to optimize communication between all the people that within the company. I discovered that there is a way by studying actually software itself. Software itself is a communication tool, typical software, any software that you buy from Salesforce or IBM. And most of the communication is done within every company through these software packages that take data in a structured fashion and communicate from one person to another. And that's really the majority of the automation we used in all these companies, just like we did. Like we took Jira and Asana and Trello and Slack, and these are all software. But although Slack actually is a different kind of software, and then the reason why Slack or email found its way into the corporations was really that the lack of or inability of traditional software that communicates information in structured fashion.
Have you ever wanted to start your own podcast? I record and publish podcasts on a platform called Spotify for Podcasters, and I absolutely love it. Essentially, you can upload from your phone or computer, and it distributes to every platform that plays podcasts. They support video podcasts, and you can make money on the platform with ads or even podcast subscriptions, something that has made my life so much easier as a podcaster. So if you're interested, I highly recommend you give it a try. You can download the Spotify for Podcast app, or go to spotify.com/podcasters to get started on your podcast today.
And that leaves a lot of holes, and because humans communicate with natural language, and natural language can cover a lot of subtleties in communication. So that the email and Slack and these tools found their way in the corporate world to really fill the gap or the inability of traditional automation in these organizations that fell short in communicating the complete picture of information. So they came in to complement that those tools, but they really created their own problems. They were promised to be panaceas, and they ended up being Pandora's boxes. And studying all of that kind of led me towards this model that I discovered, and based on that, we invented lots of interesting technologies. And I essentially discovered that there is a way of totally optimizing communication amongst people, but you can't start with the communication itself. You can't start with the message or the messenger. You have to actually start with the workflow and look at what's going on the workflow. So that's a whole, I wrote a paper on that in 2022, and it was published by IEEE. And I've got a little video we put out that kind of covers all that, and I'll make that available for you if you want to share with your audience. I think I recommend everyone to watch it because it gives a good insight into why email doesn't work. Why do we have so many problems with email? And why doesn't it scale? Or even what they call the social social media network for enterprise. Slacks and Yammers and Teams, and why don't they work? Well, I mean, they solve some of the email problems, but why are they still not perfect? Why do they fall apart? And that's because they are trying to map a very complex, multidimensional model we call workflow. And workflow is really an abstraction of assembly line. And we inherited that, we abstracted that since the early 1900s. And this is how we, as large groups of people, can get together 500, 5,000 or 50 and organize ourselves and build products or deliver services. And that's the magic of how humans are connected together. And that's where the secret is. Secret lies in making that the pivot of communication.
Yeah. And let me take a stab at explaining this concept. I'll drop a link to that video that you mentioned in the description for this for people. But let me take a stab at explaining that concept. You let me know where I fall short, and then let's talk a little bit about how you are using this to solve problems with your with Omadeus.
And how it all ties to AI, because that's really the whole. Yeah. Okay.
Yeah. So essentially, everyone knows emails have a big problem. When you have, 1,000 people in your organization and you send an email out to everyone, there's a ton of people that the email's not relevant. You've been in organizations like this. Everyone's been in organizations like this, right? You get an email about a specific project. You're not really relevant. You're not a decision maker. The information isn't irrelevant to you, but you just get a ton of like this kind of noise in your inbox. So we upgraded a little bit to the concept of Slack, where essentially you have channels, or, Microsoft Teams. You have different channels. You got the marketing channel, you have the HR channel, you have a bunch of different channels, and perhaps you're relevant to that organization, so you're in the channel. Again, the same problem as you scale up to a big organization. A lot of people can be messaging in that channel, and there's a lot of noise that may not be relevant to you.
Email doesn't scale is because if the pivot of that communication model is the individual. So that means the individual is responsible for analyzing the information and figuring out who to route it. Now, if you start scaling the number of these people from 3 to 5 to 10, 50, now each individual needs to have a very complicated routing map in their table, in their head, a routing table in their head, and be able to analyze the information and figure out who to route it to. That's a really too much task to ask any human. As it goes beyond 4 or 5, now, you got a mess. That's easy to see, right? And then in the social media model, which is like Slack and Yammer and some of these tools, that pivot shifts from the individual to the subject. Instead of saying, instead of creating me sending the information and email to you, we'll just create a channel called Paint, or create a channel called Nailing the Chair, or that. So I put information. I can now analyze that information as a human, and instead of trying to figure out who to send it to, I'll look at the content of that information and say, well, that's basically Paint content. So the assumption is that the mapping is easier. Okay. So that's the abstract model. But the problem is that you're building chairs, lots of chairs. You're making thousands of chairs. It's moving on the assembly line, right? You may be interested, a salesperson may be interested in a particular chair that's a red chair. He doesn't care about any of these chairs, but he has to subscribe to that channel that says Paint. Now he's going to get a lot of bombarding messages for better access.
Yeah.
So that's, for that example, I can kind of show why these things fail. Now, not everybody even, it's like in these models, who creates these channels? How do you name them? Like, it just becomes channels galore. Anybody who's ever used these systems, they know what happens as you add more individuals and more subject. And that's because this stuff is really not thought through or analyzed in an abstract form. These tools found their way in an evolutionary process into these corporate settings because Facebook was extremely successful, and people asked, hey, one individual can communicate with thousands of people in a nice way, and we can't do this with email. Why can't we have a Facebook thing for our company? And that actually drove a lot of companies with opportunities to try to build these tools. And, and Yammer was one of the first successful one, and then Slack became successful. And you got a lot of tools that are similar to this. But they ended up not really solving the corporate problem. And in fact, they've really exacerbated in many interesting ways, because now you have corporate data sitting in all those databases that they're being input by these automation and software that is the main nervous system of the corporation. And then you have information sitting in emails that is really the natural language, and some of that information is even duplicate. That's because you're extracting things from the database reports, you're attaching them. And then you have some of that information sitting in silos of Slacks and Yammers and Microsoft Teams. Now, so the corporate data is scattered all over the place. Okay, so that's the face of the problem that, for me as an engineer, I get very excited about, because we want to solve these problems. And this problem is prevalent all throughout the corporate world, all around the world. And as we know now, fast forward, we get to where data is oil now. Why is data oil or data is gold? Data, why? Because that's what you feed to AI. Okay, so in order to create some sort of meaningful intelligence or output from or work from an artificial intelligence engine, you need to feed it data. But your data is scattered all over the place, and this is what the success of ChatGPT that demonstrated the power of large language models. Now, a lot of corporate CEOs are asking the following questions: How do we get AI into our company, and how do we actually benefit from this, and how do we use it to create efficiencies?
This episode is brought to you by Shopify. Forget the frustration of picking commerce platforms when you switch your business to Shopify, the global commerce platform that supercharges your selling wherever you sell. With Shopify, you'll harness the same intuitive features, trusted apps, and powerful analytics used by the world's leading brands. Sign up today for your $1 per month trial period at shopify.com/tech, all lowercase. That's shopify.com/tech.
That's really this is exactly where we are right now. We're in this phase.
Yeah.
And what I see on a daily basis, and it's almost becoming repetitive, and I'm sure most of your audiences would have similar experiences, that we're beginning to see repetition of the same stories because AI is being used as a tool in a sense, and there are problems that are basically what I call low-hanging fruit. And you could easily see the application of AI, whether it's a large language model where you take a manual and feed the AI the manual or the frequently asked questions, and then you use it as a better chatbot to answer questions of your clients, or you summarize a legal document, or you fake somebody's voice, or all the wonderful things that you can do with Midjourney or Dolly. So there are a myriad of these tools that are producing a lot of wonderful results, and also help with productivity or improving productivity. But they're all low-hanging fruit, and they're all superficial. Because this way, from our perspective, that we're using AI as a tool, where we think AI itself is a platform. Similar to the fact that graphical user interfaces back in the 1980s were a platform, and a lot of software had to be rewritten, or every software had to be rewritten. The software you use today is based on graphical user interface. It's based on that computational model. And that was a major revolution that happened in the 80s and the 90s, and a lot of software companies had to change their model of writing their software. That's continuing to this day. And the same, a different revolution happened in the 2000s, and that was the transference from local area network computation to what we call cloud today, which is the internet. It's a distributive model. It's a different kind of architecture. It's a completely different way of writing software. And the way we organize as engineers is different. We have DevOps, we have back-end people, we have front-end people. It's a complete reorganization of human expertise and the way we actually approach building these systems. Now, what we see is that we are entering a new revolution, and that is the artificial intelligence revolution. And we need a brand new architecture, brand new way of breaking those business software into a new model that can take full advantage of the artificial intelligence. And we've invented one, and we call that object messaging and intelligent objects. And we feel that the major revolution and the major impact that the artificial intelligence, namely large language models, are going to have on human society is through this re-architecting all of our software for this new platform. And in that world, our software, and I'm going to explain why that is and what is our software, what's the problem with the software that we're using today, whether that's your accounting system or your electronic medical record system if you're a physician, or if you project management systems, if you're an engineer or a project manager, any software that we use, it's outdated, outmoded. It needs to be broken up, thrown out, rewritten all over again for this new platform.
So what would you say are the major shifts as far as like this platform goes, shifting from thinking of AI as a product to a platform? What do you think the biggest changes are going to have to be?
Okay, so I'll describe the story. See, when the computers showed up in the work environment, the corporate world, business, they showed up and they said, well, we're going to bring some cool automation to your place. And let's say you were a big manager in a bank somewhere or a manufacturing facility or whatever. And I'd ask you, Yaden, what's your existing process and where do you keep your information? And you would kind of describe your process. This is what we do. I, fill out this form and, and Susie gives it to Jane and Jane gives it to David. They fill out this section and it goes to the floor so I would look at that and I take all the forms as a software engineer and I would document that whole process flow and your physical process flow. And I'd draw a flow diagram, a flow chart. And then I would extract typical a data flow diagram or a control flow diagram. These are all diagrams that actually I would be using to automate your process, your physical process, and take all your forms essentially and put them on the screen on a computer. That's the model for business process automation, basically in a very simplified way. Essentially, I take your physical forms and I stick them on a screen, and then I take the data, which is structured data, and then that data is very specific, like the name, Joe, size, 15, a date, 11, whatever, right? It's like you can't put something else in, and that's very, very that's what's referred to as structured data. And that would get pushed into a database, and then it's a lot faster. It's automated. It standardizes things. You don't have to fill things out on the form of the typewriter. And the access is easier. Somebody doesn't need to put all these forms together and create a report for the high manager. You do this magical query and whatever information you want, you kind of make real-time reports on somebody's screen. And this is what we've been living with since then. That's the model. Even through graphical user interface revolution, this model didn't change. Even though we changed the way humans interact with the computer, before they would just interact with text and just read questions, they will answer the questions. But now there are objects on the screen that you interact with. Click on, right? So it opens up, it tells you something. And you move things, you drag something, you drop it somewhere else. So that graphical user interface facilitated and made human and machine interaction easier, much, much easier, and made it less intimidating. And that was really coupled with the introduction of personal computers, they were called at the time, PCs. I don't know if we still refer to them during the 80s. And so computers ended up being everywhere, but that model stayed the same. Take the forms, stick them on the screen. Even during the transition to the internet, that model didn't change. The same forms on the screens, put them on the screens that are pushed through computers that you don't see somewhere in the cloud, right? Right. Now AI is here, and we've been waiting for this. We've been waiting for this because based on the model that we created, we've been waiting for a reliable way to be able to process natural language 100% reliably. We see the problem has been so far that computers really didn't understand natural language. Okay. And it did not in a reliable way. If anything ChatGPT can demonstrate is that now we can actually understand. We can build machines that understand humans 100%. ChatGPT, for example, is not all reliable when it's generating answers. And a lot of the right. The Google people coined that, they coined a phrase called hallucination. So it can hallucinate. But even when it hallucinates, it still understands you perfectly. It makes stuff up, but that means that it just understood you. So we take that part of that technology that understands language, and we actually have designed a new approach of creating software. It's like beyond the whole taking all the forms and then sticking them on the screen. We're saying, no, look, this is an intelligent machine, and we can actually really remove the burden, a lot of the burden that we would put on humans in terms of determining who to send information to, when to send it to, where to store information, and which creating file folders, put things in this file folder, put it in that file, organizing the information. I mean, why do humans have to do this? And it's like, we've got a computer here. This computer, you can program it to play chess, for God's sake. You can't program it to file your data for you where you're supposed to be. But see, the point.
That's a good point.
Yeah, I'd really just think that's like why should I open up my turn on my phone, which is a computer, and look at there with 50,000 apps, try to figure out which one to press. Why can't I just talk to the darn thing and say, I'm hungry?
Right.
So just say, what do you feel like? I mean, did you ever see, there was a movie actually called, I think it was called Her, that was not too long ago, where a new operating system comes in, and the only interface was a natural language. Actually, it's like it's a famous movie at the time it was popular. But that's where we need to go to. We need to go where humans interact with the machine with using natural language. And graphical user interfaces are also good because a lot of times you just point at something instead of using 10 words. You can just point at something, right? So the combination of the screen and natural language could probably make the ideal user interface. But you need a different kind of architecture to build this software. And the way that architecture, the way we describe it, is instead of just taking dumb forms and sticking them on the screen and then connecting these forms together with automation and putting the data in a database, you need to go one step further as a software engineer. Actually, a few steps further. You need to, in that environment, after you talk to Yedin and he describes to you the process, is you need to go further and start doing the semantic analysis and identify the real and virtual objects in that environment. And then you need to find a way of representing those objects with programming and make those objects intelligent. There's a way of creating data around that object in traditional forms to give it, for example, I could kind of represent an X-ray. Let's say electronic medical. Yeah. I could take an X-ray and represent that as an object. I could tell it that it has attributes that you're an X-ray. The technician who took your picture was Massoud on this date. So these are all structured data. But what we can do is actually this object, now we can give it a large language model. We can insert a large language model such that it can actually communicate with humans. That X-ray object can communicate with humans using natural language. And then we add other pieces to this object. We give it ways that, imagine like diary books. We'll give it a black diary such that it can record the communication between itself, the X-ray, and the X-ray is responsible for recording that communication between the doctor, the primary doctor, and the patient. Then it will give it a green book to record all the conversations between the primary doctor and specialists and any other or nurses. So basically, we make the object intelligent and self-aware, and we give it the ability, just like a human, to process natural language. So it can not only have dialogues with humans and understand what's happening, but it can also record information. For example, if the doctor needs to have a conference call with the patient, the object itself can hold that conversation and sit there and be present and watch that conversation and record the video and store the video within itself. No longer anybody has to say, well, I'm going to put this video file in this folder and I'm going to remember that it belongs to patient Massoud, right? The object itself knows that it's an X-ray. It's present and it's actually sitting there listening. And it can listen to the entire conversation between two specialists, the doctor and the specialist. And they're talking about whether this is cancerous, it's not cancerous. And the object, just like a human, can remember and understand. And in fact, it can even do better than the normal traditional LLMs because it doesn't have to search the entire space. It knows that it's an X-ray. So it can focus, actually. So the structured data that defines that object allows it to focus and have constraints about the way it processes that natural language. At the end of the call, it may be that you and I are the doctors, and we talk about, okay, now we say, how about golf this weekend? See, the object knows, okay, this is not related to me because now they're talking about golf. So this object becomes super intelligent about itself as to what happened to it, and who the stakeholders are and how to keep track of those stakeholders. When critical information happens to itself, it knows how to navigate the workflow. It knows how long it has to stay in each stage. And it knows all the different classes of stakeholders, what kind of information to share with whom. So if you think of your system as a collection of all these intelligent objects.
TIAA is on a mission. Why? Because 54% of Black Americans don't have enough savings to retire. So in collaboration with big-name artists like Wyclef Jean, TIAA released Paper Right, new music inspiring a new financial future. With 100% of streaming sales going to a nonprofit that teaches students how to invest. Stream Paper Right now and help close the gap.
Now, what does that remind you of? There are systems like that on planet Earth. They're biological systems. Actually, a lot of biological systems are built in such a way where we have, for example, in my body, in the back of my brain, there's not a little file folder that keeps track of cell number 57 in my liver. Mm-hmm. That information is self-contained within the cell of my liver, and the liver cell knows exactly what it is. It's a fairly complex machine, and it knows its function. It has memory even. It knows how to communicate with its neighbors. It's intelligent, it's self-aware. And the collection of those cells create the liver. And the liver itself is an intelligent super component that's connected to the rest of the system through veins and arteries and nervous systems. So we're actually adopting this model and taking it to silicon and saying, you can actually represent a business or manufacturing process and go beyond just the workflow process and the basic automation and identify these virtual or real objects and represent them in your program and add LLM to them so they become intelligent, so they can process all kinds of information and interact with humans and also each other. Because if they understand LLM, these objects can talk to each other in natural language as well. They can query each other because they all have memories. They can say, hey, the X-ray could query the blood test object, or the specific object inside that blood test. The X-ray could interact with the HDL or your blood count, for example. I'm not a doctor. I don't know if that would make sense, but you can imagine relevant objects that are basically, as a software engineer, what you're doing, you're creating this framework. All you have to do is create this framework, and then you create objects and you give them life. And these objects can create super objects, and these super objects can be connected systemically to each other. And you could even design a super object that is a brain that's sitting there, similar to our brain, that the brain is sitting there coordinating the efforts and communications at a higher level between the liver and the kidneys. And so it's a lot more complex than that as an analogy. The biology of humans is a lot more complex. As a matter of fact, it's a source of the inspiration. But what we've done is actually we created this model, which we call object messaging and intelligent objects. And this is a brand new model. And based on this model, what we did is we spent quite a number of years, a few years, trying to build a platform, actually, a framework that, but this was too complex. And a lot of engineering problems had not been solved. This was brand new territory. So we decided after almost 2 years that we just pivot and build an application using this model so we can actually demonstrate to the world what this thing looks like, how it feels to interact with a system like this. So we had a problem back when in my last company that I was just referring to, trying to integrate Jira with Trello and Slack and Google Docs and all these tools and writing software. So we decided, let's solve that problem using this model. So as a result, we've created project management, collaboration, communication, documentation, powered by AI in one package using this model, such that from the moment you log into the system, at every point you're interacting with the AI. And it's implicit, it's sitting there. You can call it and you can interact with it, but essentially the system is a collection of all these objects that handle your project management. And these objects are intelligent. They know what they are. They know, for example, if they're a feature or they're a bug. They know if something happens to them. They know who to go to, who to complain to. If they sit too long in a particular stage, they'll they look at their clock like they're expired. They run around and tell their stakeholders, hey, I was supposed to be here 30 minutes, but I'm here now for 35 minutes. And it gives a chance to interact with the appropriate stakeholders. It's a fascinating experience. It's really a taste of the next thing to come. So we've kind of demonstrated to ourselves that the how to build something intelligent on the machine.
I feel like this is an entire paradigm shift for software and for project management and for so many things. This is such an interesting concept. Talk to me about like what does this actually look like in practice? Like, so you're talking about, right, you have these different elements. For some reason, when I'm thinking about this, all I can think about is like all of like the folders inside of like an organization, all the different departments that organize their projects by folders or by different things. So all of this has intelligence to all of them. How, like, what is the integration, right? Like, let's say I'm a regular corporation that uses Microsoft Teams to organize and like pretty much the whole Microsoft suite to do everything. Like, is this an integration I can pull into my current system? Do we have to recreate new systems for something like this? Well, what's this going to look like for your average, enterprise?
I think I'm pretty convinced that we're going to have to go through this tectonic shift the same way that we did during the graphical user interface revolution, where we ended up having to rewrite all this software, and as we did during the LAN to the internet, where we ended up having to rewrite all of our software. Because the current model, the way, for example, Jira is written, the way Slack is just a tool, it's basically really just trying to solve the problem of natural language and converging it with structured data. It's an evolutionary process that we're going through. And we need a merger of all of this. We need a merger of email, Slack, and your accounting system into one magical world, right? And you can't just fuse them together the way they're written. So architecturally, they have to be rewritten from scratch. So because we do need communication from one to one, in person to person, and actually the channel communications are also interesting, but they're not sufficient for representing workflow-based communication. Channels are good digital representations of departments and groups, and that's it. Yeah. But for our structured software, is what we need to do is we need to rewrite all the existing software like accounting or practice management systems or electronic medical records, and really merge all this stuff together. I'm afraid there's no other way around it. If we're going to meaningfully, deeply integrate AI into our software, okay, we need to actually break all this stuff up and start constructing our software using intelligent objects. And these intelligent objects, because they carry information, and you have human nodes that are interacting with these intelligent objects. And these human nodes are different classes of stakeholders that have something to do with the system. They have expertise that they want to give to the system. And there's information that they need from the system at the right time and right information. So if you rebuild these systems with intelligent objects, and these objects figure out how to transmit themselves, the whole object can transmit itself. The X-ray, when you are the doctor and the X-ray is taken by the technician, the X-ray knows it's an X-ray, and it knows it's a chest X-ray, and because it's designed that way, and it knows it's authorized. The minute it was taken, there's a model it's an authorized model within the system that is held somewhere in Mayo Clinic, and that has the address. The X-ray has the address. It flies over there, bounces against the X-ray model, gets a full report, and reads it and starts seeing, there are areas of concern here and there. And all of a sudden, that object flies right into Dr. Yaden's inbox and says, hey, I'm here. I look like I have some problems here. You need to really look at me. And then you basically open up that X-ray and you can query it. You could talk to it. You could,
okay. Yeah. So fascinating framework. but then I think a lot of people, it begs the question a lot of people are going to have, which is like, is this a terrifying dystopian reality where, essentially every object is a smart object interacting with itself independent of us? Is this like the Terminator situation, right?
No, well, well, I mean, I guess, and not in this phase anyhow, because what's going to happen in this phase, just think about it. Just the act of the X-ray technician knows how to take X-rays. Like bang, just to do the X-ray. So why should he go there now, drag that X-ray, drop it into a folder, type somebody's name, and shoot that message to that person? And why? That's like why should he be responsible for routing that X-ray message? And when the X-ray shows up somewhere, right, then they have to look at it and go, well, we know this Mayo Clinic has this model, so let's just send an email there and a secure email, attach this, send it over there, and wait 2 hours or whatever for that X-ray to be read, and then they'll send you an attachment document, and the doctor gets a chance to read all this stuff, right? Just think about this is all information management, right? As opposed to where with technology today, because now we have an LLM who understands that can understand perfectly natural language. You could build a system that when the minute the X-ray is taken by the technician, all he does is says, basically brings up the patient on the machine. And that, by the way, that patient object is also an intelligent object. Imagine this, all the system is written like that. And just clicks on somewhere and points the camera, the X-ray, takes the picture, and he's done. That X-ray now is aware. I'm an X-ray. I belong to patient Massoud. Okay. All right. Well, I'm X-ray of this type. Okay. So, but next, and I know my workflow because I've been programmed with workflow. I have to now examine myself through this process. Next is, okay, hit yourself against this model, wherever that model is. Boom, hit yourself against that model, wait for it to get an output. Where does that output go? It doesn't go into some folder. It goes into me. I hold all this stuff. I am that intelligent object. I keep all my information. I handle all this information. Don't worry about it. I know where to put them. I know which one is more. I'll create my own folders. I'll share them with you whenever you need it. If you want to look at that whole document, I'll give it. Oh, what would you like to know? You would like to see, because I just read the report and I've got these alerts here and I've highlighted myself with graphical stuff on the screen. I want you, doc, please look at these areas. They could be potentially cancerous or whatever the problem may be with it. But, would you like to see the full report? Here's a full report. Read it from top to bottom.
Two things that I think are incredibly valuable here. Number one is, I think a lot of the times when you're trying to get information, one of the big challenges is asking the right question. You see this with ChatGPT or anything else. Some people might ask it a question, think the output is garbage, but if you just had asked it like more specifics and more in a better way, you'd get a better output. I think this is a really interesting concept where essentially, especially when you mentioned like the alerts there, let's say you have a X-ray and it can tell you like, hey, look, I've looked at all these things. These are the things you need to be aware of. Perhaps a technician or someone is looking at some areas, but they don't understand like once they could be blindsided by a specific issue. They didn't see it coming, whatever. And if this object was able to get a broad view of information and perhaps pick up on something that you missed, that could be very valuable. That's one area I think this is incredibly interesting. Another is the concept of like building software. So I have a background in building software. I started a company called Self-Pause. It's the #1 AI life coach, and been working on that for many years. But what's really an interesting concept to me is if you had a software product, any kind of software product, and the whole thing was intelligent at its base, where essentially it was constantly learning about ways to self-optimize and, I have a bug, report the bug. Oh, here's the issue. Maybe here's the code to fix the bug. Here's the #1 feature people are requesting. Like that, it could be just, that's an incredible paradigm shift where essentially your software self-improves. Again, though, one thing I do want to ask you about is you mentioned earlier the concept of a brain. So having you got like the brain on the system that's kind of helping to orchestrate things. Like, what is that brain? Is that brain open? Like, for example, is that like OpenAI's ChatGPT model? Or is that something different? You know, get what I'm saying?
It's something, yeah. No, it's something different. So the two things to envision. If you can envision your system, whatever you're trying to automate, as a collection of intelligent objects. And it could be different. I mean, for example, we've got this project management, collaboration, communication, documentation, and it has to be all that, by the way. There's a reason why they have to be integrated, because when you create so in our system, we basically said, okay, the smallest object, is we call it a nugget. We gave it a cute name because nugget is the gold piece of information. So the nugget, a collection of nuggets, you could put them all together and make a sprint. And then you put 10 sprints together and that's your project, or 50 sprints. So you got objects that are nuggets, they become super components that are sprints, instead the collection of super components are projects. Right? And when you create, anybody can create this nugget, and you just give it a definition. It says, it's a bug. You want to report a bug, or you want a feature. You say, hey, I want a feature that, as a user, you could be a salesperson, you could be anybody. And the minute you create that object knows where to go. He's like, it belongs to this project. He just flies and finds the project manager and just flies into the appropriate inbox as a triage and says, hey, I need attention. It's like somebody create, and they can examine it. They can actually talk at that object. They can use that, open up that object, because the object transfers itself. It's the object messaging. The object is the message. And that object is intelligent. It's like it could hold all the conversation. So the project manager can start holding a conversation inside the object with the creator. And there could be other stakeholders. Other people found that object because they were looking for those features, and they find it just like a Google search, and they start following it. So they become stakeholders. And that object knows all these stakeholders. And the communication is held inside its own communication channel, because it holds it. So you don't have to keep track of where you could go in there and attach an Excel file in there, but it holds it. You can read it. You could attach a file or a link to that feature saying, hey, I've seen something similar on the internet. By the way, here's a link to that. And the object keeps track of that. So the object is the document manager, the whole thing. Mm-hmm. The object is the collaborator, that's the arbiter of collaboration between all these people. Right? So there becomes that. And it's intelligent enough because it's sitting there and it doesn't need to generate any text. So it doesn't have to hallucinate, because all it has to do is read the information about itself, right? It says, okay, it's not like it's going to go read the whole internet and you got to ask it some crazy question and it just makes stuff up. It knows that it's a feature that is a button of this size, and it's that when you press it, something happens. Here's the action. It knows all that. And it understands the conversations between the stakeholders. But it also knows the workflow. So if it's assigned to a programmer and the programmer says, I'm going to start coding this on Wednesday. Thursday comes up, the object wakes up, says, nobody did any work on me. They didn't report anything on me, so I assume they didn't do any work. I'm going to show up, and I actually calculate how fast this guy is. It doesn't look like he's going to be able to finish me by Friday, based on everything that I see. And it actually knows a lot of information about you, and I won't get into how, because if you're constantly working on these things, the whole system, the brain, gets an idea about how good is Gideon estimating. Because he constantly, about 23 percentile, he overestimates, he's too optimistic about his hours, right? He's always off about 27%. So the brain actually learns, and the object has access to that information. So it figures out, no, Yaden is not going to be, he said to the project manager, I'm going to finish me Friday. Okay, I don't think so. So it flies all the way through and goes into the inbox of the project manager, and that particular inbox is called bad news. Just like your Gmail, the way everything is sorted out, like messages. Yeah. Interesting enough, when you go to object messaging and intelligent objects, your interface, the interface to your system becomes streamlined. All interfaces for all systems are going to look like messaging system, like Gmail, and it just makes sense. And actually, this was very surprising to us, because this is another segue I could take into the approach to design. I'm not one of those people who we believe in designing using in the beginning. You don't worry about user interface and user experience. You start solving what we call plumbing problems. Just start with the plumbing. Make sure your plumbing is coherent. You have minimum number of rules. Your grammar is very, very small, and so you come up with, then you have compatibility with the way you build your objects and your databases. This is a very interesting approach, and allow the user interface to emerge, so to be free with that. And that we adapt, and then we don't actually start with user stories. We make user stories, but we validate our systems with user stories at the tail end. Like, it's like, because you don't want to start with, that's a top bottom approach. We have a bottom to top approach. And that's a whole different subject, but our system started looking like a messaging system. And we said, duh, object messaging, of course. And that's going to streamline. And we made a lot of interesting discoveries because it's moving towards where once you have a system like that, essentially you can actually hook up a microphone to it and you don't have to train anybody about anything. You just go in front of the system saying, show me all my projects. And it just knows that it knows the navigation to that system because it's built like a very simple tree structure, like a messaging. It just goes to the right module, pulls, it shows you all the right projects. And you look at it and go, well, why is that one delayed? The third one, get into that one. You just talk to it and nobody ever trains you. So we're getting very, very close with this model towards that universal interface as well, where the main interface between the machine and the human is natural language and visual elements are pointing at this. So we know there's a brave new world that's waiting, but in this phase, it's not going to turn into the Terminator. I have to disappoint you with that.
Okay. What do you think? You talked a lot about the fact that this is like a total, conceptually, I mean, this is kind of a total rewrite, ground up for a lot of software and other things. What do you think the biggest challenge you will face, companies will face in implementing a vision like this? Like, what's the biggest pushback? What's the hardest part of actually making this a reality?
Yeah, well, you put your fingers on it. It's the big corporations are going to be late in, just like the big companies are going to be late in adopting this model. But this is a force of nature. It's a tsunami that's about to come. We're going to have to, if we're going to create efficiencies in a meaningful way, and be able to use AI for what is really, really valuable in our society. I mean, we impact our society via these organelles that we call corporations and companies. Okay, so of course we go out and play together and then eat together and do all kinds of fun things together as humans. But the way we impact the planet even is through these machines we call corporations. And I mean, I gave a talk and I use this example. It's like, you drive through any Western cities, you look up, all these beautiful, shiny buildings, 50, 100 floors, full of educated people with master's degrees, PhDs in different backgrounds, bachelor's degrees, finance, medical, all kinds of stuff. Can you imagine ChatGPT as an engineer, since you've got engineering background? Can you imagine ChatGPT eating all their jobs as Sam Altman predicts the white-collar jobs are going to go away? And if you can imagine it, fine. That's almost like science fiction, but as an engineer, how? I mean, I'm an engineer. You've got a software background and probably an engineer, because if you're into software, you're an engineer. Can you imagine the steps that are required for that? That's the question. And this is what we're talking about, object messaging and intelligent objects. That actually describes step by step how to do that. You point out, and in fact, we're not going to replace these jobs. What we're going to do, we're going to make them efficient. We're going to remove the burden of information exchange and information storage and information management from humans and give that back to the machine. Humans need to be human experts at their jobs. They know, they have the wisdom, they have the decision-making. We are basically making them extremely inefficient by forcing or burdening them to create, once the information is created, to organize it, sort it, put it in the right place, route it to the right person at the right time. And these systems, if you imagine the nervous systems of these corporations being the software that's really connecting all these humans together. Now that's the structured software, that's the form-based software. And then you have email, and then you have these silos of these channels, information scattered, all those. These machines cannot be efficient. Imagine an amazing merger of all these different systems together where objects are intelligent and they're taking care of information exchange at the right time, right place, to the right person, and showing up in front of you saying, hey, Yaden, this is what's the matter with me and I need attention. And you can tell me to go away, or you can ask me questions. Any question you want, I can answer you. The expert can show up, say, I don't even know you. I don't remember you as an X-ray. So, Dr. Schaefer, you don't remember me? 2 months ago, you had a conference call with Dr. Alibakhsh about me, and you said this. Would you like to see that? I can bring that out of my memory. These 7 seconds. Here it is. I'll play it for you. That's actually accessing the video that happened, and it's stored it, right? Now it's part of its memory. Now this is self-awareness. Now information is residing where it needs to be residing. It's with that object. You don't need to file it in some folder according to your way of thinking. And Susie needs to do the same thing. And we have all this duplicate information. It is, if you at one point, when that stuff happens to a normal brain, it becomes diseased. We come up with the way it's calling it different things, dementia. And at a very core level, if you take a neural net, and when you start a neural net, these are a bunch of cells that are organized together hierarchically, and you kind of connect the lower layers to the higher layers and higher layers, so on and so forth, and you assign random links to these connections. In the beginning, it's not very intelligent. It's actually that can't do anything useful. Let's say you want to train this neural network to detect a cat in a photo, so you get good statistical sample of cat photos, because you can't get all the cat photos in the world, and you come up with all kinds of fancy algorithms and you train it. Once it becomes smart, you show it a picture with 2 whiskers. It says, there's a cat right in the corner. It's better than even a human, right? If it's trained. You open up this box, see, where is this intelligence? Where did this go? You see, actually, the links changed. The way you started, it's like, oh, now this one just completely disappeared. That link right there just fires 20% of the time. Intelligence amongst these cells, because the cells are the same cells. Intelligence for performing a particular function, detecting a cat, amongst a bunch of cells, is in the way they communicate in an optimized manner. Information is transmitted from the right cell to the right cell at the right time. If you take human beings in an organization and apply the same analogy and say humans, assume the humans are the cells in this body. And if you can find a way of guaranteeing that the right message goes to the right person at the right time, which is an optimized model of communication, you have created maximum collective intelligence. And this is going to create unbelievable efficiencies and unbelievable earnings. These companies, any company that adopts these models, their efficiency is going to go through the roof. And humans are going to be happiest.
What do you think the CapEx for like instituting one of these systems would be? Like, I mean, when we're talking about like earnings going through the roof, let's say you're a publicly traded company, you're like, I'm not going to be one of the slow guys. I mean, we have a bunch of Fortune 500 company listeners on that listen to this podcast. They want to implement a system like this. What are they going to have to spend in order to implement something like this? And what does that look like?
Well, my recommendation to them is if they have got any software project that are developing right now, they need to stop and they need to start thinking in this direction. They need to retrain their the software engineers and the designers. And it's not that complex, actually, to be honest. But we actually hold seminars. We do webinars online, and we're doing free webinars and discussing this model. And we go through one product we've created, which is this project management tool. And we also give a free trial of this such that they can manage a small project and experience it firsthand. Because once you experience it, you're not going to go back. Once you experience it, you realize this amazing tectonic shift. It's a completely different world. Now you're dealing with an intelligent software. Because when you logged in, you're dialing anywhere you are. Imagine there's a chat GPT is there and it knows where you are, who you are, what you're doing, what your action is. And in fact, it can collaborate with you.
And is this something that small businesses as well can take advantage of, right? Like, let's say we have a couple small software companies listening to this. They got 5 or 6 employees. They don't want to miss out on this next wave. What advice would you give to them?
I would say this is your golden opportunity. I mean, every company that you know today in technology, they were born during the dot-com days, every major company or past that. And they took advantage of this shift from local area networks to the internet. In many ways, even Google took advantage of that. I mean, if we were still sitting on local area networks, there would be no search engine, no Google, right? It's I mean, the look at Amazon. It's an application that's running on the cloud, basically, right? Salesforce, for example. They were created, and actually I was one of the first customers in the back in the .com days. They were giving it away for free. They took advantage of this shift from local area networks, so they built a CRM for this new platform, and now they're a monster company. So I would say they're in luck. This is your golden time. And any entrepreneur, software engineer that's thinking about some cute little tool they want to build, or some little application, build it using object messaging and intelligent object. We call it OMU for short.
Incredible. Okay, Massoud, thank you so much. I know we got to wrap up the show today. Thank you so much for coming on and sharing this incredible concept. So much personally that I have to digest and start rethinking about some of the things I'm working on. And I'm sure a lot of people are like that. If people want to be able to reach out to you, ask you more questions, test out your platform, what's the best way for people to find you and your platform?
Okay, so the product is called Omadeus, Omadeus, and OM actually stands for object messaging, and www.omadeus.com. They can go on there and read the information, and we also make available the 2 papers that were published by IEEE. Just the recent one was published a few months ago. And actually, we were awarded the Innovation of the Year by the Computer Science, Computer Engineering over this invention. And they can register for a webinar, and they can read the papers. And we've got some instructive videos. We've got a lot of Q&A stuff that explains more further and how AI is related to this. So if you're a software company or technology company, sign up for a webinar. If you're want to try out the software, just sign up. There's a place where you can do a free trial on the website. And we're very excited by this. I think the future is extremely exciting. And there are going to be a lot of new companies being born through this revolution.
Incredible. Well, I'm super excited. I'll have to check that out as well. I'll leave links in the description for the listeners. Thank you again, Massoud, so much for coming on the show and sharing all of this. For the listeners, thanks so much for tuning into the AI Chat podcast. Make sure to rate us wherever you get your podcasts, and have an amazing rest of your day.